Okay, students, we're going to do a quick summary of Mod 1 Topic 2. You need to know all your vocab words on page 101, line, ray, segment, circle, etc. That's one problem on your test. Then our next main concept of the whole chapter is transformations. We either have isometries, which another word for that is rigid motions, or we have dilations. Dilation, you either have an enlargement or reduction. And remember, you look at the image and compare it to the pre-image. If the image is larger, then it's an enlargement. If the image is smaller, it's a reduction. And to find that scale factor, we do image divided by pre-image. You did a worksheet on that. All right, so back over the isometries, which is the main focus. Okay, all isometries are congruent. What does that mean? Same size and shape. Okay, we could have a single reflection, which would have just be one reflection. We could have translation or rotation, which is two reflections. Okay, and we could have a glide reflection, which is three reflections, a reflection and then a translation. Okay, now remember what you need to know for this test, for the edge elastic here, is a reflection is over a line. Okay, so if you see a line, you know you're dealing with a reflection. A translation is over a segment. Reflect in the same direction. Remember we talked about it was A to B, you go left to right in that same distance, parallel to that segment. If it's a rotation, you're going to have a circle. Okay, so if you see that, you know it's a rotation. You see a segment, you know it's a translation. If you see it's a line, you know it's a reflection. Okay, and then you might have a lowercase next to one of the arrows. That'll be line N. Okay, translation, they use capital R, T. Reflection, they use capital R. Rotation, this book uses capital R. But if it'd be a circle, it'd be rotation, it'd be like center E, if that was the name of the circle, and like 90 degrees. For example, how many degrees are rotated. Translation, you'd have the direction you want it to go. Translation, say A to B. So that means moving it from left to right. That same distance and parallel to it. Okay, and a glide reflection is a reflection, a single reflection, and then a translation. So remember, a single reflection is 1, and then a translation is 2 for a total of 3, which is why we have a 3 right there. Now, the DCAS does not use the word glide reflection. It says a combination of reflections and translations, okay, or combination of your rigid motions, and that would be a reflection and translation. Now, remember, when it's an odd number, these two, it switches orientation. Now, remember, orientation means it's either clockwise or counterclockwise. So orientation is either clockwise or counterclockwise. So if it switches orientation, then it was either done by a single reflection or by a glide reflection, which again is a reflection and then a translation, or vice versa, a translation or then a reflection. If it does not switch orientation, so same orientation, both clockwise or both counterclockwise, it doesn't matter the orientation, but if it stays the same, then you have a translation or rotation. Remember, translation, the shape would look exactly the same, just shifted or slid. Okay, versus a rotation, the whole figure would rotate. Okay, so if it looks the same, so that'd be like a translation, for example, of A to B. So it went up in that direction, the exact same amount. So there's my distance, that same distance right there from A to B, and it's parallel to it. Okay, that's a translation. Versus this would be a rotation. Okay, because the pre-image and the image were different. They weren't looking exactly the same. It got rotated. Okay, so switching orientation for 1 or 3, a single reflection and glide reflection. Okay, and remember to know if it's 1 or 3. If for example, we had that one that it reflected over the first it didn't give you this one. Okay, so to know if it was a singular reflection, remember I said to go ahead and take two corresponding, well, let's go ahead first off and name them A, B, C. Okay, there's my right angle, there's my right angle, so that's C prime, B prime, A prime. Okay, so I could check my orientation. ABC is counterclockwise versus A prime, B prime, C prime is clockwise. So it switches orientation. So therefore it has to be either a glide reflection or a single reflection. Well, remember if it's a single reflection, I could take the corresponding points, A and A prime, find the midpoint, right about there. Take B and B prime, find its midpoint, right about there. I connect them, and there be my line of reflection. But notice this original pre-image does not reflect directly across and give me my final image. It takes me to this one right here. And then from here, I translate down. So this is my single reflection, and this is my translation down that took me to the final image. So there's your reflection and translation for a glide reflection. Okay, line of symmetry is a reflection line that maps the figure back onto itself. So if I took a square, okay, then I could have a square is a regular polygon. If it's a regular polygon, then it's going to be the number of sides. It's how many reflection lines it has. Where are these? I could split it there. I could split it there. I could split it there, and I could split it there. Okay, all those lines would reflect back onto itself. Okay, so there'd be 4 reflection lines. Okay, if I have a hexagon, regular hexagon would be 6. And rotational symmetry is always going to deal with regular polygons. And remember that formula is 360 divided by n, where n equals the number of sides. So if we had that square, 360 divided by 4, which equals 90 degrees. So every 90 degrees, it would rotate back on itself. So I'd have 90, 180, 270, and the next one would be 360. My rotational symmetries have to be between 0 and 360. It cannot include 0 or 360. So if I add another 90 on there, it would give me 360, but remember, it cannot include 360 and it cannot include 0. So there would be my rotational symmetries for a square. Okay, so if it said plural symmetries, I name all of them. If it just said rotational symmetry, I only name the smallest one, or my first one, 90 degrees. So you have to pay attention where it says symmetries, plural, then I do 90, 180, 270 for square. Versus if it said rotational symmetry, singular, I only give the 90 degree one, or the first one that I get when I do 360 divided by the n. Okay, that summarizes this whole unit. You notice there's very little math outside of this 360 divided by however many sides there are. Everything else is translations, rotations, reflections. Okay, let me just do one quick drawing right here. Remember, if I see a circle with a point, and I have this triangle right here, that's my pre-image. Let's call this T, that Q, and this R. So I say I have a circle, so it's a rotation from P to Q. That takes me to right there. And then I see I have a segment. A segment is a translation. then a translation from where? Q to R. You have to name the points to get the full, if you want full credit. Okay, and last one that I did in class was, let's say, I have that. And okay, so notice I see I have a segment right there. So that's a translation. Translate from P to Q. And then I notice I have a line in. Well, remember, if it's a line, it's a reflection. So then I'm going to then reflect. Then that's a reflection over line in. Okay, and that takes me to the image. That was the pre-image right there. So if I see a segment, I know it's a translation. If I see a line, I know it's a reflection. If I see a circle, I know it's a rotation. Okay, so you've got two of those. You got to pop out on the test. Okay, knowing that. All right, that'll summarize everything. 12 minutes.